Good afternoon, class. Now, this is one of my favorite topics of the whole semester. It involves something that we're all familiar with, and that is car collisions. So we're going to talk about impulse and momentum, and what happens to a person in a car when they slam into like a wall. We're going to use that as our example. But in order to do the first thing is to get the equation for impulse and momentum. So I'm going to go up here on the board. I'm going to start with Newton's second law. Then that force equal to mass times acceleration. F equals ma. And then what I'm going to do is I'm going to replace a. I'm going to go over here and remember an old friend of ours. V equals at plus v sub 0. And rearrange this until we get a is equal to v minus v sub 0 divided by t. And I'm going to put this equation in for a right here. Of course, this is a very simple way of doing this type of a problem. It's going to be m times parentheses v minus v sub 0 divided by t. And then I multiply both sides by t, becomes f times t. And the other side will become m times v, the final momentum, that's the final momentum. And then minus m times v sub 0, and that's the initial momentum. So this is called impulse, and that's called change in momentum. Now frequently you run into this kind of stuff. If you hit a golf ball with a golf club, you can definitely measure the mass of the golf ball, its velocity before impact. You can figure out its velocity after impact, but you really can't figure out the size of the force because it's very difficult to estimate the time of that collision. So let me just go to a simple example over here, and this will be a student in a car. The student weighs about 110 pounds. They have a mass of 50 kilograms. They're traveling about 40 miles an hour, 20 meters per second, and 50 times 20 is 1,000. Now 50 times 0 is 0. Now suppose this collision occurs and it only takes you 1/10 of a second to stop. And actually that's not realistic because usually it's less than that. The impulse is going to be different because the time, we're just going to use it as a nice example. So suppose the time was 1/10 of a second. You work this out and you find out the force on your body was 10,000 newtons. Now if you divide that by 4.45, it comes out to well over 200 pounds, but actually this number is probably not accurate. It's really shorter than that. Now just to give you an example before we go to the next one, suppose you're in your room and you run across the room and you flop in your bed. The bed softens your impact, then increases the time. As the time goes up, the force is going to go down. As the time goes up, the force goes down. So here's an example of the same person, maybe a young lady, 110 pounds, 50 kilograms. She's in her car, about 40 miles an hour. Minus 1,000, she slams into the wall and she stops, but she has an airbag. The airbag opens up, it takes a lot longer, maybe 2 seconds for her to stop. And as she stops in 2 seconds, you work out the force on her body comes out to be about 500 newtons. And the reason is that because it's good stopping her. It's negative for that reason. So comparing 10,000 as compared to 500, you can definitely see the advantage of having an airbag. And time goes up, and in the case of you in your room, flopping on the bed, suppose you miss the bed and just hit the floor. And then you crawl for your mother, okay? Just because you guys go like that. That's a really short time, and you hurt your hands if you do this, and you also probably mess up your beautiful nose if you also do that. So this is impulse momentum. Now, what are the features about cars? And my assistant can step down now, sit down, and I'm just going to talk about this. What happens in cars? Well, this is in the book. There's a whole section at the end of chapter 7. I talk about 1987. My 1987, my wife wanted a new car, so we went to a Pontiac dealer. And she was going to get a Pontiac Grand Am. Well, the salesperson, they always think the men is for the men, so he's talking about the horsepower and the styling and that sort of thing. And I said, no. this is for my wife and the children. And so suddenly his entire demeanor stopped at that point, and he talked about the different safety features in the car, the windows and all that sort of thing. But also he raised the hood, and he showed there's weak points in the hood. So if there's a collision, the hood does not come back into the passenger compartment. It actually folds up like a V, and that's talked about. Also, in the modern cars, talking about the modern cars now, of course, they have the airbags, side airbags, front airbags, etc. But also the cars are designed, and there's weak points in the engine mounts. And what will happen is the engine will actually drop to the roadway. And so if you survive the collision, you can get out of your car, and there's your engines lying on the roadway, and you say, what happened? And that's one of the things that's been known to happen in the last 30, 40 years because of airbags and the ways the cars are designed. Now also the design of the modern cars, the cars are supposed to crumple. And I'm going to show you a video of an accident that my wife had. She was traveling on Southwest 104th Street going east and a straight line, slow speed, maybe 30 miles an hour. This young lady, she decided to turn into an apartment complex. I guess she wasn't paying what she was doing. She turned in and hit in my wife's car and put a big dent in the front bumper. And the only thing that came out of good of that was I'm glad I was not driving the car because it was my wife's favorite car, and she would have gotten very mad at me if that had happened. That little fender bender, we took it, and fortunately the lady had Geico. It was $1,300 to get that car fixed. They had to replace the front bumper. It was a mess in that particular case. My wife's car is a brand new 2013 Honda Fit. So it's almost, 7 years old? But she loves that car. And if you have an accident and it's your car, or worse yet, your parents' car, and you have an accident, and what do? You always blame somebody else. But fortunately, I was there, I saw exactly what happened. So the windshield is designed not to break into big pieces and cut you. It's designed to actually shatter little pieces. The front bumper is designed to crush. Now there was a 1976 Ford, I'm trying to remember the name of it, but I cannot remember. In the back of the car, the gas tank was not properly positioned. And what happened was there was a collision. This is, 50 years ago now? Almost 50 years ago. 40 years ago. The gas tank actually was crushed and burst. Gas began to flow, and I happened to a member of the school board. His daughter was died in that collision because it caused a fire. The two young 19-year-old girls were killed in that collision. They had stopped for a traffic light. The truck came up behind them, didn't stop, crushed their car. They also apparently couldn't get out the doors when it happened. And the two girls died, and it was awful. Now, hopefully that won't happen to anybody. You know, things do happen. Good things, bad things do happen to good people. And bad things happen to good people? Yeah. Good things happen to bad people? Maybe not. Depends on whether you get lucky in this life or not. All right, I think I could go on, but I think my assistant is saying it's time to stop for today. All right, thank you. Bye-bye.